Welcome to MEI Mechanics. We're on the topic Impulse and Momentum 2, Collisions in 1D, and this is video 2.3, Successive Impacts of Spheres. Now just another reminder of a couple of things. We've got the coefficient restitution, which is defined as the separation speed divided by the approach speed, and that has to have a value between 0 and 1, where a value of 1 would indicate a fully elastic collision. And it's only in an elastic collision that there's no loss of energy. So usually when we have a collision, kinetic energy is lost, and that's in the form of heat and sound, and therefore the change in the kinetic energy is always going to be negative. Now here's a typical example of a problem involving three objects where we're considering successive collisions of these objects. Now we're given some information initially. We're told that we're given the initial velocities of the three objects, and we're told that after the first collision, because obviously if we look at these numbers we can see that A and B are going to collide first, that after that first collision that they then have velocities of 3. A now has a velocity of 3 meters per second, and B will have a velocity of 5 meters per second, which means that B will then go on to collide with C. We're also given that the coefficient restitution is the same in both collisions, and we're asked to show then that there'll be no further collisions after B and C collide, and therefore to find the total loss in kinetic energy. So for the first collision, we can see then that the separation speed is 5 minus 3, and the speed of approach is 7 minus 3, and that allows us to work out the coefficient restitution, which is a half. And we were told that that's going to be the same in the second collision. So now when we consider the second collision, we can firstly think about the coefficient of restitution. So if we look at the speed of separation in the second collision, that is Vc minus Vb. Divide that by the speed of approach, which is 5 minus 3. We know that that is also equal to a half, and that simplifies to Vc minus Vb equals 1. And if we also consider conservation of momentum, that tells us that 2 times 5, which is the momentum of object B initially, plus 1 times 3, which is the momentum of object C, that will be the same after that collision, where it's 2 Vb plus 1 lot of Vc. So that tells us that 2 Vb plus Vc is equal to 13. And now if we solve these two equations simultaneously, we end up with the result that Vb equals 4 and Vc equals 5. So this is the situation after those two collisions have taken place, and if we look carefully at the three velocities now, they're all to the right, and each one's increasing as I go from one particle to the next. We've got 3, then 4, then 5. So that means of course that they're now all moving away from each other, and therefore there won't be any further collisions. Now the final thing to do is to think about the change in kinetic energy, because that was also part of the question. So all we need to do is look at the final kinetic energy. So it's a half times 1 times 3 squared for this object, half times 2 times 4 squared for this one, and a half times 1 times 5 squared for this one. And then similar thing using their initial velocities, and we find that the difference between those kinetic energies is minus 5 joules. So the kinetic energy lost is 5 joules. So that concludes video 2.3, Successive Impacts of Spheres. The final video on this topic, 2.4, will be Successive Impacts with a Smooth Plane.